Hello, my name is Patrick Taryn, and I'd like to share some info about my modeling process for the midterm. First of all, I went through the property data for both the 2016 and 2017 data sets, and I went through each variable to determine their worthiness of being in the model. As many of you saw, as all of you saw, there's a lot of missing data in each of these files. About half of the variables, at least in this 2016 chart you see here, were missing most of their data. A lot, however, I noticed were flag variables that showed the presence of an item in a property such as a pool or a patio, things like that, or indicated the size of that item. So what I did there was I decided to just assume that those variables were correct for my modeling process, and I'll get to that a little later. But the other variables that, not like these, that had lots of missing data, I wasn't comfortable with imputing them, so I decided to throw them away. Second, once I narrowed down the variables based on missing data, I took another look at what they were conveying, and I noticed a lot were either redundant, such as numbers of bathrooms by different types, like quarter bathrooms, full bathrooms, or square footage of different areas in the house. These were a bit redundant because there were aggregate variables that took into account like number of bathrooms as a whole or the total square footage. So I decided to use the aggregate versions instead. Some other ones were a little bit difficult to use for myself, bit out of my wheelhouse, such as geographic coordinates. I didn't quite know how to use these. I think they would be valuable, but I decided to use more of the higher level geography variables such as zip code or county. As far as imputation goes, I decided to use median imputation for some of the numeric variables. For others, though, I actually created a one-step decision tree imputation method based on the property land use type ID, which accounts for the type of property or the type of building that is on the property, such as a house, store, condominium, such as that. I felt like that variable would be important for imputing number of bathrooms or square footage, so I used that. And then, as I mentioned earlier, some of the flag variables that had a lot of missing data, or some of the numeric variables which indicated size of certain items on the property, such as patios or pool, I have either imputed the null data as 0, or I created a separate flag variable based on those numeric size variables, and basically indicate whether they have a patio, a garage, a pool, things like that. Regarding outliers, the chart here shows that these are some of the numeric variables, and all of them are highly skewed right. So what I did was I imputed the 99th percentile value for any data that was higher than the 99th percentile. Lastly, I created some time component variables based on the data in the training set. Whenever the transaction date was, whenever its month was, I created a month variable, also a year variable based on the transaction. And then also I created an auto-regression proxy, which basically took the average log error from the previous month of when the transaction would happen. Before creating the model, I merged the 2016 and 2017 data sets, and I divided these into training and test data. The models that I decided to use were all based on linear regression. There were 3 models. One, which I call the baseline, had just external regressors, no time components. I expected this to do the worst since time components are an important part of the predictions. As far as picking which regressors to use, I used the stepwise variable selection process. And I actually used these external regressors for all 3 of these models. For the second model, though, I added the month and the year. And then the third, I added month, year, and then the auto regression proxy variable. As far as performance, in the chart at the top, you can see that all these models perform fairly similarly. I think the baseline, they'll perform the worst, which I expected. Models 2 and 3 performed very closely, but I think ultimately I would choose the autoregression proxy variable as my, or it's the model with the autoregression proxy variable as my chosen model. There were ways I would like to improve these models, either by using more of those refined geographical location variables, more time series terms, or just exploring more modeling techniques besides linear regression. Thank you. Bye.